Our solar system is a vast and mysterious place, a cosmic neighborhood filled with wonders and secrets waiting to be uncovered. We live on Earth, a small planet orbiting a yellow star, our sun. This star provides the energy that sustains life on our planet, making it a unique oasis in the vastness of space. But far beyond the familiar terrestrial planets, Mercury, Venus, Earth, and Mars, lies a realm of gas giants and icy wonders, a region that challenges our understanding of planetary science. This is the outer solar system, a region shaped by extreme cold and powerful gravitational forces, where temperatures can plummet to hundreds of degrees below freezing. The outer solar system begins beyond the asteroid belt, a region populated by rocky remnants from the early solar system. These asteroids are like time capsules, preserving the history of our solar system's formation. Here, we encounter the gas giants, Jupiter, Saturn, Uranus, and Neptune. These colossal planets are composed mainly of hydrogen and helium, with swirling clouds and dynamic atmospheres. These massive planets are vastly different from the rocky inner planets. Their immense size and gaseous composition set them apart, making them fascinating objects of study for astronomers and scientists. Their enormous size and composition make them fascinating objects of study. Jupiter's Great Red Spot, a massive storm larger than Earth, and Saturn's intricate ring system are just a few of the features that captivate our imagination. The outer solar system is also home to a diverse collection of moons, some of which are larger than planets in the inner solar system. These moons, like Ganymede and Titan, have their own unique characteristics and mysteries. These moons exhibit a wide range of geological activity and atmospheric conditions. Io's volcanic eruptions and Enceladus's icy geysers are just a glimpse into the dynamic processes at work on these distant worlds. They are like miniature worlds, each with its own unique story to tell. Europa's icy surface, with its potential subsurface ocean, raises intriguing possibilities about the existence of life beyond Earth. Exploring the outer solar system allows us to piece together the history of our solar system and understand the processes that led to the formation of planets and moons. Spacecraft like Voyager and Cassini have provided invaluable data, expanding our knowledge and sparking our curiosity. The secrets held within these distant worlds can shed light on the origins of life itself. By studying these remote regions, we gain insights into the conditions that may have led to the emergence of life on Earth and potentially elsewhere in the universe. Jupiter, the king of the planets, reigns supreme in the outer solar system. Its swirling clouds and the Great Red Spot, a massive storm larger than Earth, are iconic features that have fascinated astronomers for centuries. Its massive size dwarfs all other planets combined. Jupiter's immense gravitational pull has a profound influence on the solar system, acting as a shield by capturing or deflecting comets and asteroids that might otherwise threaten the inner planets. Saturn, the ringed wonder, captivates us with its elegant beauty. Its rings, composed of ice and rock, are a marvel of nature, stretching out over 175,000 miles, but only about 30 feet thick. Uranus, the tilted ice giant, intrigues us with its unusual axial tilt. This tilt causes extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. And Neptune, the blue giant, mesmerizes us with its stormy atmosphere. The planet's deep blue color is due to the presence of methane in its atmosphere, and it hosts some of the fastest winds in the solar system, reaching speeds of over 1,200 miles per hour. These gas giants are primarily composed of hydrogen and helium, the lightest elements in the universe. Their vast atmospheres are layered with clouds of ammonia, methane, and water, creating a dynamic and ever-changing environment. This composition reflects their formation in the early solar system when they accreted vast amounts of gas and dust. These primordial materials coalesced under gravity, forming the massive planets we see today. Unlike the rocky inner planets, the gas giants lack solid surfaces. Their atmospheres are thick and deep, gradually transitioning into a dense, hot interior that may contain a core of rock and metal. Instead, their atmospheres gradually transition into dense, hot interiors. This transition zone is a region of intense pressure and temperature where hydrogen exists in a metallic state, conducting electricity and generating magnetic fields. The gas giants are also characterized by their strong gravitational pull. This gravity not only shapes their own moons and rings, but also influences the orbits of other objects in the solar system. This immense gravity shapes their surroundings, influencing the orbits of moons and capturing passing objects like comets and asteroids. Jupiter alone has over 79 known moons, each with its own unique characteristics and history. Their gravitational influence extends far beyond their visible atmospheres, shaping the dynamics of the entire outer solar system. This influence helps to maintain the stability of the solar system, preventing chaotic interactions between planets. Understanding the gas giants is crucial to understanding the formation and evolution of planetary systems. By studying their atmospheres, magnetic fields, and moons, scientists can gain insights into the processes that shaped our own solar system and others. Their unique characteristics provide valuable insights into the processes that govern the birth and development of planets throughout the universe. The study of gas giants not only helps us understand our own cosmic neighborhood, but also informs the search for exoplanets and the potential for life beyond Earth. The outer and inner solar systems are like two distinct families. The inner solar system is home to the terrestrial planets: Mercury, Venus, Earth, and Mars. These planets are small, rocky, and close to the Sun. They are composed primarily of heavy elements like iron and silicon. In contrast, the outer solar system is dominated by the gas giants: Jupiter, Saturn, Uranus, and Neptune. These planets are massive, gaseous, and far from the Sun. Their composition reflects the abundance of light elements in the early solar system. This stark difference in size and composition stems from the conditions present during the early solar system's formation. The inner solar system, closer to the Sun, was hotter. This heat prevented volatile substances like water and methane from condensing into solid ice. As a result, the inner planets formed from heavier elements that could withstand the intense heat. In the outer solar system, the temperatures were much colder. This allowed volatile substances to condense into ice, which became building blocks for the gas giants. The abundance of ices in the outer solar system contributed to the massive sizes of the gas giants. The gas giants are not solitary wanderers in the vastness of space. These colossal planets, with their immense gravitational fields, have gathered an entourage of celestial companions. They are accompanied by a retinue of moons, each with its own unique story to tell. These moons are not just passive satellites, they are dynamic worlds with fascinating characteristics and histories. These moons range in size from small, irregularly shaped objects to large spherical worlds with complex geology. Some are mere kilometers across, while others rival planets in their dimensions. Jupiter boasts a diverse collection of moons, including the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. Discovered by Galileo Galilei in 1610, these moons have been the subject of intense study and fascination. Io is the most volcanically active body in the solar system. Its surface is dotted with hundreds of volcanoes, some of which erupt with lava fountains reaching heights of up to 500 kilometers. Europa harbors a subsurface ocean that could potentially support life. Beneath its icy crust lies a vast, salty ocean, kept warm by tidal forces exerted by Jupiter's gravity. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. It has its own magnetic field, a rarity among moons, and a surface marked by a mix of older, heavily cratered regions and younger, less cratered areas. And Callisto is a heavily cratered world, a testament to the early solar system's bombardment. Its ancient surface has remained largely unchanged for billions of years, providing a window into the past. Saturn is renowned for its magnificent ring system, a vast collection of icy particles that orbit the planet. These rings are composed of countless fragments, ranging in size from tiny grains to massive boulders. These rings are thought to be remnants of a shattered moon or comet that ventured too close to Saturn's gravitational pull. The resulting debris spread out to form the intricate and beautiful structures we see today. Saturn also has a diverse collection of moons, including Titan, the only moon in the solar system known to have a dense atmosphere. Titan's thick, nitrogen-rich atmosphere is reminiscent of early Earth and has intrigued scientists for decades. Uranus and Neptune also have their own systems of rings and moons. Though less prominent than Saturn's, these rings add to the mystique of these distant worlds. Uranus's rings are faint and dark, composed of large particles and dust. In contrast, Neptune's rings are clumpy and uneven, with bright arcs that stand out against the planet's deep blue hue. Triton, Neptune's largest moon, is unique in that it orbits the planet in the opposite direction of Neptune's rotation. This retrograde orbit suggests that Triton may have been captured by Neptune's gravity rather than forming in place. The moons and rings of the gas giants provide valuable insights into the processes of planet formation and the evolution of planetary systems. By studying these celestial bodies, scientists can learn about the conditions and events that shaped our solar system. They are miniature solar systems in their own right, offering endless opportunities for exploration and discovery. Each moon and ring system is a world unto itself, with unique features and mysteries waiting to be uncovered.